Okay, so on to question 14. How do you calculate the concentration from absorbance? Okay, so to help us answer this question, I'm going to talk about the Beer Lambert Law, or the Beer Lambert equation, which basically just shows that absorption is directly proportional to concentration. So let's say I had a simple graph and I had concentration as my x-axis and absorbance as the y. And if we were to plot the absorbance values of a species that increased in concentration, you'll kind of get something that looks like this. And then if we were to plot this and show the line of best fit, you get a straight line going up. And in simple like terms, when you just have y equals mx plus b, it's basically the same thing. So y, the absorbance, is equal to the slope times just concentration. But for the Beer Lambert law, our slope has a value as well, and they are just constants. So I'll write out the actual equation here, and then I'll define what all the terms mean. So C, as you can guess, is concentration. And we mentioned A to be absorbance, which is unitless. E is something called molar absorptivity. And the B is the light path length. So this is usually given to you in the question. Sometimes it's just 1 centimeter. Yep, so that is how one would calculate concentration from absorbance. So let's see what the junior tutor said. The Beer Lambert law, or Beer's law, describes the relationship between the attenuation of light as it traverses a material and the properties of that material. Beer's law shows the linear relationship between the absorbance and the concentration, molar absorption coefficient, and length of the light path of a solution. This is mathematically expressed as A equals molar absorptivity times B times C. Absorbance is unitless because the units of the 3 other parameters will cancel out. Concentration should be measured in molarity, or moles per liter. Light path is usually reported in centimeters, and the molar absorptivity is usually reported in liters per mole times centimeters. To calculate for concentration from absorbance, 1, if the absorbance, molar absorptivity, and light path are given, we can simply plug in these values in the equation to solve for the concentration. 2, if we are given a set of experimental values of absorbance and concentration, and we need to determine an unknown concentration from a known absorbance, we need to plot the values with the form y equals mx plus b to determine the values of slope and y-intercept. Wow, that was a very formative answer. Okay, so I like how they had a use of having two different scenarios where one needs to calculate for concentration from absorbance.